Hello everyone and welcome to lesson 8.2.1 part 2. Okay, today we are going to pick up where we left off yesterday. Yesterday we got cut off a little bit. We're going to start with problem 8-39 just so that you can get to the right spot in your notebook. Now today we're going to start shifting gears a little bit and we're going to focus on rewriting numbers in scientific notation. You asked me, Mr. McCoy, what in the world is scientific notation? Scientific notation is an easier way to write really big numbers, okay? Or it could be really small numbers, but we're going to focus on the really big numbers first. And ultimately, where we're going to end up today is, can I tell which number is bigger? When I look at scientific notation, which number is bigger? These are the two learning targets that we're going to start with. Now, yesterday we learned the powers, right? We learned, if we were focusing on this one, okay? When we're multiplying, we added the exponents. That's where we were yesterday. This is all information from yesterday's lesson. So let's go ahead and pick up with problem 8-39. It said, multiplying a number by 10 changes the number in a special way. Simplify each expression without using a calculator. As you work, pay attention to how the number changes when you multiply by powers of 10. Now, what you should have noticed is the decimal moved once. Letter B, the decimal moved twice. Number 3, the decimal moved 3 times. Letter 4, the decimal moved 4 times. And the connection that you are supposed to make here is 1 0, 2 zeros, 3 zeros, 4 zeros. That power of 10 told us how many times to move that decimal place. So in problem letter 8-40, using that pattern, how many times can I move that decimal? Well, as I write this problem, I'm going to write 9.23, and I'm going to move that decimal 7 times. So I'm going to take my pencil on that decimal, move it once, twice, 3, 4, 5, 6, and 7. And I fill in with zeros. Okay? This is problem letter A. This is based on the pattern that you just noticed. Now, this is scientific notation right here. This is called standard form. Standard is the way that we always write things, regular numbers. So notice, answer to B, describing what we just did, the non-zero part of the number stays the same. The decimal moves to the right 7 places, and zeros are added at the end of the number. Okay? This is how scientific notation works. It's focusing on the non-zero numbers, but because we're in base 10, we're looking at, okay, how many times, how many spaces did that decimal place move? Problem letter C. If you were to generalize this statement, each time the number is multiplied by 10, notice an exponent tells you how many, the decimal point moves 1 place to the right. And that's because the exponent is positive. To the right is making it a big number. Positive is a big number. Okay? This is the general rule of how scientific notation is working. Now, let's go ahead and jump into problem 41. This is where you are starting off. This is at the top of your page. When astronomers describe distances in space, oftentimes numbers are so large that they are difficult to write. Right? Scientific notation is an easier way to write numbers. For example, the diameter of the sun is 1,390,000 kilometers. Wow, that's a lot of letters. Or this enormous number. To make these large numbers easier to write, this is the key. Scientific notation is making numbers easier to write. Astronomers and other scientists use scientific notation. In scientific notation, the diameter of the sun is this number. So, question letter A. I want you to write the scientific notation. Write it out. And if I were to take this number and actually multiply it out, this means 1.39 times 1 million. Okay? That's what it means. When you are doing 1 times 10 to the 6th power, it means 1.39 times 1 million. 1 with 6 zeros. So if I had a calculator, boop, boop, beep, boop, beep, boop, boop, I would get 139, whoop, 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 0, 0, 0, 0. Notice this is the math of it. So I notice this turned into 139, the non-zero number is still there, and I move that decimal 6 times. You need to be able to move that decimal according to the power that is there. Problem letter B. Now, the mass of the sun is 1.99 times 10 to the 30 kilograms. Now, notice how easy that is to write. Now, what does this number mean? Well, it means 1.99 times, I don't even know what that number is. But I know that that's a 1 with 30 zeros. So, how do I do this problem? Well, I'm going to write 199. And I am going to move that decimal. Yes, you are going to write it out. You are going to move that decimal 30 times. Now do the math in your head. If you are moving that decimal place 30 times and 2 of the spaces are used for the 9 and the 9, how many zeros are you going to write? It's not 30. 2 of them were used up for the 9 and 9. So how many zeros? 28 zeros. You need to write 199 with 28 zeros. That number is enormous. Pause the video and write it out. All right, welcome back. Now, if you wrote out all those zeros, you can tell that scientific notation is definitely helpful for writing numbers in an easier way. Okay, 8-42. Scientific notation always has 2 things. Now, I'm just telling you this. If you wanted to jot this down, this would be really helpful. But scientific notation always has 2 things. The first thing, scientific notation always has 1 number in front of the decimal point. It cannot be 0. It cannot be 10. It's got to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are your only 9 options. Okay? Notice in our previous example, it was 1.39. It was not 13.9. It was not 0.139. Okay, notice it had 1 number in front of the decimal. Second thing, it always uses this multiple sign and never a dot or a parentheses. Never that. Okay, it always has times 10 and a power. Whereas the power tells you the number of places the decimal moves. Okay, these are the basic facts of how scientific notation is working. So let's look at A, B, and C. Problem letter A. Nope, I notice that there's something wrong. I notice that it has too many decimal places. So you're going to write 2 spaces. That's wrong. And you should probably, I didn't make a table, so you should probably write wrong. 2 spaces. Now, if I'm going to fix this, I know that 2, 5, 6, 1, nope. The decimal's here. 1, 2, 3, 4. I need to turn this into correct scientific notation. Well, I want the decimal place to be here. I want it to be 2.56 because I only want 1 number in front of that decimal place, not 2. So I'm going to write times 10 to the what power? Well, 1, 2, 3, 4, 5 decimal places. I can't, my loops didn't add up, but it is to the 5th power. I want you to notice I added a decimal place and I added an exponent. So there's letter A. Letter B. They have the correct number of spaces, but they are missing times 10 to what power? What number is 100 as an exponent? Well, that's 2 zeros, so it's 2. It's missing times 10 squared. So the correct fix-it is 5.46 times 10 squared, or to the second power. Problem letter C. Do you notice how it has a 0 in front? Not allowed to do that. Okay, it has no, and I know 0 is a number, but you need a number 1 through 9. So it's missing a number. Missing a number in front. Okay, and to fix it, well, I need to move this decimal place over. So if I'm going to move that decimal place over, 9.3 times 10 to the power. Now up here, we added a decimal place, so we added an exponent. If I take a decimal away, I need to take an exponent away. So instead of 8, it will be 7. Correct scientific notation is a way that we write numbers. But there has to be a standard form of scientific notation so that people aren't just willy-nilly doing whatever they want. It's just like with your first and last name. We use capitals, right? We have a first name and a last name. We don't mix it up. Okay, so let's go ahead and practice writing these in scientific notation. Okay, if I had the number 314000, don't write this down, but if I were to turn that into scientific notation, I first of all think, where do I want my decimal to go? Right here. So I write 3.14. And then I think, okay, I have one number in front of my decimal, times 10. To what power? And I count. 1, 2, 3, 4, 5, 6. That is turning a number into scientific notation. I want you to write letter A and turn it into scientific notation. I want you to write problem letter B and turn it into scientific notation. Pause the video to do those problems. All right, let's move on. Final problem. 8-44. Scientific notation makes large numbers easier to write. Yep, we said that. It also provides you with quick information about the sizes of numbers. For example, Pluto and Haumea are both dwarf planets. Pluto has a mass of 1.305 times 10 to the 22nd kilograms. I'm glad I don't have that right now. And Haumea has a mass of 4.06 times 10 to the 21 kilograms. Which dwarf planet is larger? Some people are tempted to look at numbers like we normally do. Say, oh, the 4 is bigger than 1, so Haumea is bigger because 4 is bigger than 1. But this is in scientific notation. I want you to notice 22 is a higher power than 21. That is like answering the question, which is bigger, 13 or 4. If you wrote these out in standard form, it would line the place value up like this, 13 and 4, instead of 1.305 and 4.006. In this case, Pluto is bigger. Notice we got a sentence. Both numbers are written in scientific notation. The exponent tells you which number is greater because the greater power is the bigger number. Okay? Now, this is a quick run through on what scientific notation is. If you want to check for understanding today, go to the back of your notebook. You'll notice it's blank. at the top, write today's date, the exit ticket. Can you answer these 3 questions? These are the type of questions that I need you to be able to do after going through this. If you can do these 3 things, you did your job. If you have no idea what this is, maybe you should rewatch this video. We'll see you tomorrow.